All right, welcome everyone. I am absolutely thrilled to share today's explainer with you. We're going to unpack one of the most enchanting, beautiful things you can ever witness in the sky. Yep, we are talking about rainbows, and specifically the amazing step-by-step science of exactly how they're formed. We're going to break down the physics so simply that anyone, even a kid learning this for the very first time, can completely grasp the magic happening right above our heads. So let's just dive right in. Okay, picture this. You're standing outside just after a really heavy summer storm. You know the vibe. The air smells incredibly fresh, those dark, heavy clouds are finally moving away, and suddenly, boom, a massive, brilliant arch of color just stretches right across the sky. It honestly feels like magic, right? But it makes you wonder, what secret ingredients are actually needed to paint the sky like that? What exactly is going on up there to create such a huge spectacle?
Well, let's start with part one, the recipe for a rainbow. So, for literally thousands of years, humans made up all sorts of magical stories about rainbows. Like in ancient Norse myths, they actually believed rainbows were this magical bridge called the Bifrost, connecting the human world to the realm of the gods. Super cool. But the real scientific recipe, it's surprisingly simple. You really only need three things. First, you need sunlight. Second, you need water droplets floating in the air. So rain, or honestly even just mist from a waterfall or your lawn sprinkler. And the third ingredient? Well, it's an observer. It's you. You literally have to be positioned right in the middle with the falling rain in front of you and the sun shining brightly directly at your back. Without all three of those things lining up perfectly, the rainbow just isn't going to happen.
Moving on to part two, inside a single raindrop. To really understand how this works, we have to zoom way, way in. We're going from the giant sky all the way down to a single tiny floating drop of water. Because when sunlight hits millions of these drops, they act like tiny little optical machines. Inside every single drop, three incredible physics tricks happen in just a fraction of a second. Trick number one is refraction. Now, refraction is really just a fancy science word for bending. See, light travels at different speeds depending on what it's passing through. So when a ray of sunlight leaves the air and crashes into the surface of a raindrop, it actually slows down because water is thicker than air. And that sudden change in speed, it causes the light ray to physically bend and change direction as it enters the drop. Okay, trick number two is reflection. You can just think of this as bouncing. Once that light ray has entered the water droplet and bent, it travels straight to the back inside wall of the raindrop. But instead of just passing completely through the back and out the other side into the air, some of that light hits the back wall and bounces right back toward the front of the drop, heading straight back in your direction. And finally, we have trick number three, dispersion. Let's just call this splitting. So sunlight looks white to us, right? But it's actually made up of all the colors of the rainbow, all packed together. When that light enters the water and bends, not all the colors bend the exact same amount. Red light bends a little bit less, and blue light bends a little bit more. And because they bend differently, that white light literally splits apart into all the different beautiful colors hiding inside it.
So here is the absolutely crucial takeaway. This epic three-step journey is happening in the blink of an eye. The sunlight enters the drop and bends, refraction. It hits the back of the drop and bounces, reflection. And finally, it exits the drop, spreading out as it leaves, dispersion. One single ray of white sunlight goes in and a gorgeous beam of split color comes out.
Just tracking the ideal path of that light ray perfectly illustrates what we just talked about. If you follow the sunlight coming in from the left, you can visually trace its path right as it enters at the top, bends slightly, and travels to that back wall. Then, boom, it bounces off the back and exits out the bottom front of the droplet, traveling in a straight, colorful path directly down to the viewer's eye. And the crazy part? Every single droplet in a rainstorm is doing this exact same thing at the exact same time. All right, part three, splitting the light. Now that we know how a raindrop acts like a twinny machine, let's talk about the colors themselves. We actually have the legendary scientist Isaac Newton to thank for this one. Hundreds of years ago, using a glass prism, he proved that white sunlight is a hidden mixture of 7 main colors: red, orange, yellow, green, blue, indigo, and violet. And guess what? A raindrop acts exactly like Newton's glass prism. A super handy trick to remember them in perfect order is to use the name of a make-believe guy, Roy G. Biv. Every time you see a primary rainbow, it will always be in this exact order, with red on the outside edge and violet on the inside edge. But here's something you might not actually know. The size of the raindrop completely changes how the rainbow looks. Seriously. Think about a lawn sprinkler spitting out big, heavy drops of water.
Those large drops create a really bright, narrow rainbow with incredibly vivid, punchy colors. But as the drops get smaller, like in a really fine, misty rain, the light waves actually interfere with each other differently. This makes the rainbow much broader, and the colors get way softer, overlapping into these beautiful pastel hues. So the size of the drops literally dictates the flavor of the rainbow.
Which brings us to part 4. Why is it curved?
We've looked at single tiny drops, but obviously when you look up at the sky, you don't see tiny drops. You see a massive arch. So why isn't it a straight line or, I don't know, a square? The answer lies in a very specific number: 42 degrees. Thanks to the laws of physics, the red light always bounces out of the raindrop at exactly a 42-degree angle relative to the incoming sunlight. So, to even see that light, your eye has to be at that exact 42-degree angle from the drops. And if you think about it, the only geometric shape where all points are exactly the same angle away from a center line is a cone. The raindrops that bounce light back to your eye are forming a giant cone pointing right at you. And the base of a cone? That's a circle. Okay, this next part, honestly, it's one of my absolute favorite facts in this entire explainer. In reality, a rainbow shape isn't a bow at all. It's a complete, perfect circle with you standing right at its exact center. Seriously, if you were lucky enough to soar high above a rainstorm in an airplane and peer down out the window, you wouldn't see an arch at all. The complete, perfect circular structure of the rainbow would just reveal itself right beneath you. It is mind-blowing. So, why do we only see a bow from the ground? Well, the Earth's horizon simply gets in the way. The ground physically blocks the bottom half of that perfect circle. Obviously, there are no raindrops hovering beneath the dirt to bounce the light back up to you. So the horizon basically just cuts the circle in half, leaving us with that beautiful, semicircular bow that we all know and love.
All right, part 5, double bows and moon bows.
If the conditions are absolutely perfect out there, you might spot some truly magical variations. Like, have you ever seen a double rainbow? They are spectacular. A regular primary rainbow happens when the light bounces just one single time off the back of the raindrop. But sometimes, a bit of that light gets trapped and bounces a second time inside the drop before it finally leaves. This second bounce creates a secondary rainbow floating just outside the first one. And because of that extra bounce, 2 really amazing things happen. The second bow is much wider, and the colors are completely flipped upside down. Red is on the bottom, and violet is on the top. And what about at night? Believe it or not, the moon can make rainbows too. Remember, moonlight is really just sunlight reflecting off the moon's surface. So, on a really bright night with a full moon and some rain falling, that moonlight can enter the raindrops, bend, bounce, and split exactly like it does during the day. But because moonlight is so much dimmer than direct sunlight, it creates what we call a moonbow, which is this faint, delicate, incredibly ghostly-looking rainbow glowing in the dark sky. I want to leave you with one final, mind-bending thought to take away from this explainer today, because a rainbow is an optical illusion created by a cone of light pointing exactly at your specific eyes. It actually moves when you move. If you take a step to the side, the rainbow steps with you. The person standing right next to you, they're looking at completely different raindrops. That means no 2 people ever see the exact same rainbow. It's a completely unique light show, painted by the universe just for you. And if the universe is painting illusions just for your eyes, you have to wonder, what other invisible wonders are hiding out there just waiting for the exact right light to reveal them? Keep looking up, everyone, and I'll see you next time.